Hello, guys. Welcome to another beautiful session of our studies on rational functions. Today's studies is on domain of rational functions, where we are going to study how to exclude the input values that makes the function undefined. Now, now let's proceed to the understanding the domain of rational functions. The understanding of the domain of rational functions. The domain of a rational function is the set of all real numbers. That is, we are talking about all the possible values of x, except where the denominator is 0. Now, why are we saying that? Because division by 0 is undefined, and hence we must exclude all values that makes the denominator 0. So if you have a fraction and the denominator of the fraction is 0, the whole fraction becomes undefined. That is, to put it in a layman's understanding, it becomes mass error. So we don't want to get mass error. That is why we are studying this particular section of the rational function. Now, for a rational function written as r of x equal to f of x divided by g of x, the domain is such that x is defined for all real numbers. This x that you see in the rational function is the input value and also the independent variable. This input value must define for all real numbers with the exception of those values that will make the g of x goes to 0, with the exception of those values that will put g of x to be equal to 0, which will make the whole function undefined or goes to mass error. So now, let's learn about the steps to find the domain of any rational function. And the steps will be coming with a very unique examples for us to understand this particular concept. So let's listen to the step 1. The step 1 is saying that we should be able to identify the denominator. That is the most important thing, because it's the denominator that will give us headache. Now, the second one is, after identifying the denominator, we should set the denominator not equal to 0. Now, after doing that, we should solve to find the values of x to be excluded from the function. That will make the denominator goes to 0. Now, let's listen to this particular example. Determine the domain of the rational function f of x equal to 1 divided by x minus 2. Now, the first step is saying that we should identify the denominator. So if I look at this particular function, what is the denominator? The denominator is x minus 2. Now the next step is to set the denominator not equal to 0. Now to set the denominator not equal to 0, then from this particular example, we are going to write x minus 2 not equal to 0. The final step is to solve to find the values of x to exclude from this particular function. So now we are going to solve for the values of x to be excluded. So when you look at this one, when minus 2 crosses the equal sign, it will be x equal to 2. So it means that if I am going to conclude to write my set of domain, then it's going to be in this form, in a word statement form like this. This x, the input variable x, this independent variable x that we are seeing in this particular function, is said that the x is defined for all real numbers such that x is not equal to 2. It means that any number in the world can be substituted in this particular function for us to get an answer, except 2. Why? Because 2 will not give us an answer, but rather mass error. So here, mathematically, we can write this statement as S is defined for all real numbers, but S cannot be equal to 2. So this completes the solution for this particular example. So that is how we find the domain of a rational function. Now let's move to the graphical representation of rational function. We are finding the graphical representation of this particular rational function. And when you look at this function, the domain of this function, as we saw, is x is defined for all real numbers, except when s is equal to positive 2. So this one is telling us that the graph of this particular function will be moving and moving and moving freely along all the axes, all the values of x, but it will never and ever crosses the value of 2, the part where s is equal to 2. So for this particular function, the s is equal to 2 will be a vertical asymptote to the function. So if you look at the function, this red line becomes the graph of s equal to 2. So look at the red line. And this red line will be excluded from the function because the blue line is the function, and the function will be moving very close and close and closer to the 2, but it will never cross it. For example, look at this left side of the graph, left side of s equal to 2, and left side of s equal to 2, and the right side of s equal to 2. So when you look at this right side, you'll be seeing the graph moving closer and closer to 2, but it will never crosses it to the other side, because the moment s becomes 2, the function becomes undefined, that is mass error. So it is far or excluded from the movement of the function. Then look at the left side too. The left side is also defined, but it will never crosses the line s equal to 2, because the moment it crosses, it becomes mass error or undefined. So it can never crosses to the next section or next part of s equal to 2. So this graph represents the domain of a rational function. So anytime you are learning about rational function, the graphical nature of it, you have to look at the point where the function will be excluded, that is undefined. The function will never crosses that particular part. So let's look at this real life analogy, real life situation here. Here, think of this like trying to divide a cake among people, maybe birthday cake. If no one show up to the party, can you divide the cake? No, you can never divide the cake because you don't know the number of people coming for the party. So division by 0, no people, is impossible. That is exactly why some s values that will put the function to 0 are excluded from the domain of a rational function. So now, since we understand it, let's proceed to more expanded and examples for us to get understanding of the rational function, the domain of rational function that we are studying today. So here we have f of x equal to 5x minus 3, all divided by 2x minus 14. So what is the solution for this particular question? We want to find the domain. Now we are going to set the denominator to be not equal to 0. So doing that, we have the denominator, which is 2x minus 14, not equal to 0. Then we solve for the x values that's supposed to be excluded. So the minus 14 will crosses the equal sign. Then we are going to have 2x not equal to 14. Dividing both sides will give us x not equal to 7. So the domain will be written as s is such that S is a member of all real numbers with the exception of x equal to 7. So S cannot be equal to 7. So that is the domain for this particular function. So we have to also find the domain of the function p of x equal to 3x plus 1 divided by x squared minus 9. So in doing that, then we need to set the denominator to 0, not equal to 0. So here we are going to write x squared minus 9 not equal to 0. So here when we have to expand this and solve the value for the x that will make this denominator not equal to 0. So here we are going to write s minus 3 s plus 3 quadratic or difference of two squares. So we are going to take each of them at a step, one at a step. So here s is not equal to 3 or s is not equal to minus 3. So if I want to write a domain, then the domain is such that s is a member of real numbers, but s cannot be equal to 3 or s cannot be equal to minus 3. So this completes the domain for this particular rational function of p of x. Now let's move to another example. We are supposed to find the domain of this particular rational function. So here the solution will be the domain is such that the denominator must not be equal to 0. So s cubed plus x squared not equal to 0. I'll try to expand and factorize the left side completely. So x squared is outside, x plus 1 not equal to 0. So here x squared not equal to 0 or x plus 1 not equal to 0. When we solve this, we are going to have s not equal to 0 or s not equal to minus 1. It means that any moment you substitute 0 in this function, the denominator will be 0 and everything here will be mass L. It also means that anytime you substitute negative 1 into this particular function, the denominator will be 0 and everything here will be mass L. So if I want to write the domain will be such that s is a member of R, but x cannot be equal to 0 or x cannot be equal to negative 1. So this completes the solution for the domain of h of x. Now we have a question and a try work for you. Determine the domain of the function g of x equal to x plus 5 divided by x squared minus 4 and send your results to us through this particular channel. Don't forget to follow or subscribe to this channel to continue to receive the best of high school maths education.